Here is another problem or another couple of problems of using permutations or combinations. And these are word problems, and the trick here is to figure out whether we're using permutation or combination, which formula to apply, and then to figure out what's the n and what's the r. Once we've got all that, we can just crank out the numbers. Um, in permutation, order matters. So in situations where the order makes a choice different, then that's where you use permutation. If you have a situation where the order doesn't matter, whether it be the same thing, whether they were mixed up in any order, then you can use combination. Let's read this first part and see if we can decide whether this is a permutation or a combination. It says there are 12 European cities that Janet would eventually like to visit. On her next vacation, though, she only has time to visit 4 of the cities. One on Monday, one on Tuesday, one on Wednesday, one on Thursday. She is now trying to make a schedule of which city she'll visit on which day. How many different schedules are possible? And assume she'll not visit a city more than once. Okay, so since we're talking about schedules, I think the order does matter here. Let's say you went to London and then Paris and then Amsterdam and then Prague. That would be one schedule. But going to Prague first and then Paris and then Amsterdam and then London, that would be a different schedule. So, I mean, that's how schedules work. What you a certain thing you do on a certain day. So I think order does matter here, and we'll have to use permutation for this one. The next step is just figuring out what's n and what's r. The total number of cities that Janet wants to visit is 12, so I think that's going to be our n. And then she's choosing 4 for this particular trip, so that's our r. So now we can go ahead and do the permutation. So we'd have 12 factorial over n minus r over 8 factorial. And then when we cancel out here, we're going to get the 12 times 11 times 10 times 9, and then all of the rest of that, 8, 7, 6, 5, 4, 3, 2, 1, that's what would cancel with this 8 factorial. So this is going to be our answer, 12 times 11 times 10 times 9. So let me punch that in my calculator. 11 times 10 times 9, and I'm getting 11,880 possible schedules for this trip. That's a lot of choices. All right, let's look at the second one. It says to log onto a certain computer account, the user must type in a 4-letter password. In such a password, no letter may be repeated, and only the lowercase of a letter may be used. How many such 4-letter passwords are possible? Okay, so I think this is another case in which the order matters, because if your password was ABCD and you typed in DCBA, it wouldn't work, right? So the order does matter. So this is another permutation. We'll use this formula again. Our total is the number of letters in the alphabet. That's our n. So that's this 26 here. And then the person who makes the password chooses 4, so that's our r. Okay, so we will have 26 factorial, oh boy, this is going to be a big number, over n minus r, so that's over 22 factorial. And then when we do our cancellation, we'll have 26 times 25 times 24 times 23, and then all the numbers 22 and down will cancel with this. So this is our answer. Let me punch that into my calculator. 26 times 25 times 24 times 23. And I got 358,800 combinations, or yeah, permutations. So even in a password that only has 4 letters, you get quite a few choices of how to put those together. So that is some more work with permutations and combinations.